Hello, welcome back to my channel. If you're new, welcome to Absolutely Math. In this video, we are going to go through example problems for composite functions. Our first example, we have these two functions, g and f. G of x is x squared minus 1. F is defined by 3x. And what we have to do is create a composite function with the input of 1. Find f of g of 1. Alright, we have our first example here. G of x, f of x, and we have to find f of g of 1, or create a composite function with the input of 1. All we have to do here is return to how composite functions are defined. Well, a composite function is a function of the form here, f of g of x, which is equal to f of g of x. So let's use this and work through the problem. Alright, so we know that f is 3x and g of x is x squared minus 1. So all we have to do is plug in g of x into f of x. So that would be f of x squared minus 1, which is just g of x, is equal to 3 times x squared minus 1. In the place of x here, we put x squared minus 1. In the place of x, we put x squared minus 1. We're plugging in g of x. We get 3x squared minus 3. We just distribute the 3. That's what we get. So we've found that f of g of x is equal to 3x squared minus 3. But the question asks us to find f of g of 1. So all we have to do is plug in 1 into this composite function. So in the place of x over here, we plug in 1. And we would get, down here, f of g of 1 is equal to 3. Instead of x, we have 1 squared minus 3, which is equal to 0. And there we have it. Here we have our second example. We're given three functions, f, g, and h. F is defined by f of x is equal to x squared, g is 3x, h is x plus 1. And we have to find h of f of g of x. Alright, so we have our three functions here and we have to find this composite function. Let's rewrite it and then we're good to go. So how can we rewrite this? H of f of g of x. Well, instead of two functions, which we're used to, we have three functions now that make up this composite function. So we should write h of f of g of x. Compared to when we had two functions, we used to write f of g of x. However, here we have three, so it's h of f of g, and then finally the x is inputted into g. So we notice g is the input to f, and then that makes up a composite function in itself, which is then inputted into h over here. Great. So let's work sort of from the inside here. The inside is basically a composite function, f of g of x, which we're used to working with. So let's take it out. And we have a f of g of x. It's a composite function in itself, as you see. So we're inputting g of x into f. And we know that this is going to be equal to, so f is x squared, as you can see over here at the top. And we're plugging in g of x. And g of x is 3x. So in the place of x here, we would be putting 3x, because we're plugging in g of x, which is 9x squared. So we found f of g of x is 9x squared. So we can return back here and we see f of g of x is being plugged into h. So we could write h of 9x squared, because 9x squared is essentially f of g of x. And we would plug in 9x squared into h. We know h, the function h is x plus 1. Now instead of x, we'd be plugging in 9x squared. So we have 9x squared. And there we have it. We have found h of f of g of x, which is equal to h of g of x, which is equal to 9x squared plus 1. Thank you for watching. My email is down below. Send me anything math related, suggestions, questions, and I'll see you in the next one. Goodbye.